Okay. Hello, my name is Shanda Naomi Onela, and together with my colleagues, Elisabeta Spunei, Cristian Paul Chioncel, Gheorghe Ștefan Mătăsaru, and Florina Piroi, I developed the paper name Analysis of the Operation of a Photovoltaic Hybrid System, Electric Grid Diesel Generator Group. This work appeared as an identified need at the company where I work. 3 photovoltaic installations were installed at the company at different times and later connected to the grid. The company being at the end of a 220 kilovolt power line, there were many times interruptions in the power supply. These interruptions also put the photovoltaic systems out of operation, the inverters being of the on-grid type. As the company I work for manufacturers diesel generator sets, we designed and implemented a scheme to connect the diesel generator set and the photovoltaic system in parallel to ensure power supply when the grid voltage is missing. In this paper, the transient regime caused by switching from the diesel generator set to the grid and from the grid...
Sorry, can you hear me? Sorry to interrupt you. I don't see your presentation. If you want to button bit F5.
The presentation is viewed, but only the content of the presentation.
The rows, please. Okay.
It's okay now?
Yeah, yes,
Button.
it's okay. Yes.
Okay. In this paper, the transient
You don't
regime...
see you don't see against your presentation on your slide. Nu vedem prezentarea ta vis-a-vis de ce prezinți. Dă-i un F5 și la fiecare prezentare dă-i un buton.
Eu acum doar spun și...
Ok, nu, acum vrei tu. No, bine. No,
nu am foarte mult pe PowerPoint, doar...
ok, scuze.
Este doar PowerPoint-uri, am doar câteva puncte și vorbesc.
Scuză-mă, sorry.
It's okay.
Don't forget to change the slide. This is the conclusion.
Yes, it's okay. Where is the slide? In this paper, the transient regime caused by switching from the diesel generator set to the grid and from the grid to the diesel generator set with the photovoltaic system in parallel is analyzed. The paper is structured in 5 chapters where we present a short introduction, the hybrid solar grid diesel generator system installation, the measurement of the amount of electricity supplied by the photovoltaic system during 1 year from its application, the analysis... Sorry?
Yes, okay, go on.
Okay. The analysis of the transient regime of the hybrid system and conclusions. It is known that solar energy has long been used to produce electricity. Between 2010 and 2020, the cost of producing electricity from solar system fell by 82%, and Europe-wide, energy produced in photovoltaic system represent 5.5% of gross electricity production. The user's hybrid installation is supplied via a 3-phase transformer from the 20 kilovolt grid, and the customer is supplied via 3 circuits according to the scheme. On circuit 1, we feed the 60 kilowatt photovoltaic installation, where is it located on a hall. We feed the customers in the test hall, painting hall 2, and office building 1. On circuit 2, where we also have the 25 kilowatts photovoltaic installation, we feed the customers in the laser hall, bending and welding hall, material sheet, and painting hall 1. On circuit 3, where we have the 40 kilowatt photovoltaic installation, we feed the customers in assembly hall 1, assembly hall 2, and office building. The diesel generator set of the hybrid plant has an output of 360 kilowatts, a speed of 1,500 RPM, supplies standardized single-phase and three-phase voltage at a frequency of 50 Hz and supporting a current of 587 amps. 200 kVA total installation power. The total installation power of the consumer is 236 kilowatts. To identify the amount of energy produced by the photovoltaic system and the chat taken from the grid, we used a dedicated application, which was available in February 2023, when the last 25 kilowatt photovoltaic system was commissioned. It should be noted that the photovoltaic systems were purchased only from the user's budget, as we had not previously carried out of a study dedicated to identifying its efficiency. In this table, we have shown the amount of monthly energy consumed from the grid, from the photovoltaic system, and feed into the grid. The analysis showed that during 1 year, the total energy consumption was 256.2 megawatt hour, and the amount of energy produced by photovoltaic system was 121.47 megawatt hour. This represents 42.21% of the user's consumptions. For the analysis of the hybrid system operation, we made the recording on 12:04 in the time interval 4 p.m. to 5 p.m. For the measurement, we use a network analyzer at the scenario analyzed was: the customer takes electricity from the diesel generator group to the photovoltaic system, synchronized with it. We reconnected the grid the moment that diesel generator set went out of operation and the inverters synchronized with the grid. A period followed where the consumers was taking power from the grid and the photovoltaic system. In this picture, we have shown the transient process analyzed, namely how the phase voltage vary. During the period when we took power from the generator and the photovoltaic system, there was a 5.98% increase in the voltage on phase B compared to the standard voltage of 230 volts. Analyzing the value average of a period of 10 minutes, the voltage on phase B had an increase of 5.04% compared to the standardized voltage. In this image, we have shown the variation of phase voltage in the transient mode caused by grid reconnection and synchronization of the photovoltaic system with the grid. The duration of this regime was 2.3 seconds period, in which it is found that for 0.05 and the voltage decreased to 0. This decrease deregulated the technological process, causing rejects of the process parts in the laser cutting machine, or even failure at the equipment. When operating with the voltage taken from the photovoltaic system and from the grid, the phase voltage are very close to the standardized value. The highest value being 232.14 volts on phase A, i.e. an increase of 0.93%. In this image, during the transient process caused by the disappearance of the voltage from the grid and the startup of the generator, or the synchronization of the photovoltaic system with it, it was found that no null value of the voltage appeared on the three phases. The duration of this transient regime was 1.6 seconds, and after synchronization, the voltage value per phase were within the maximum limit of 5%. In this picture, we have shown the variation of the current on the three phases during the period analyzed. The highest value of the current was identified on phase B with a value of 58.28 amps. At the same time, a roughly symmetrical loading of the three phases is observed, with the current varying between 55.71 amps and 58.28 amps. In this picture, we have shown how the frequency varied over the period analyzed. It can be seen that the frequency was stable during the period when the customer was taking energy from the grid. During the period when the user was taking electricity from the photovoltaic system in parallel with the diesel generator, the frequency decreased to 49.923 Hertz, i.e. by 0.154% of the standard value. In conclusion, the behavior of the hybrid plant can't be estimated from simulation, but electrical measurement must be performed. Analyzing the amount of energy produced by the photovoltaic system, it was found that it represents 42.21% of the user's energy consumptions during the period analyzed. Considering the period quality, the average value of the phase voltage was 236.886 volts, i.e. 2.99% higher than the standard value when operating the photovoltaic system with the grid. When operating the photovoltaic system with the diesel generator set, the value of the phase B voltage does not meet the requirements of the standards, being 5.04% higher than the standardized value. The duration of the transient regime is quite short, but solutions need to be found to ensure continuity of supply. Thank you.
Thank you very much for your presentation. If there are any questions about